Okay, let's get started. Okay, so let's go to the data, right? And go into the R. So now this is Unit 9, right? So you go to the folder and you will see they are again they are PowerPoint file and actually a zip file, right? So unzip the file, and you will have you should have a folder called 09 regression. Okay, so and within the folder you will see actually we only have two notebook here. See that? No problem, right? Okay, so let's start with 9A. Again, you need to set this as the working directory. Open 9A, and you actually can also open the HTML in your browser. Let's take a look at the HTML first. Okay. Now, first of all, we need some package, and we need to prepare the data, right? So the data is actually still the wholesale data. Okay, let's go into R. So if I run the first chunk, I run the second chunk, I run the third chunk, so I will have the data, right? Yeah, 9A is 9A, and go here and you can press this button and you will see that you have a data frame W. Okay, you still remember this data frame? This is the wholesale data, right? Okay, there's a wholesaler and there are 440 retailers, right? So every record is a retailer, isn't it? Okay, and and these are the number, the purchase number, historical purchase number of each of the retailer. Okay, these are the historical purchasing amount, right, of different category of product by each of the different retailers. We have 440 retailers. Okay. So what we want to do is we want to like build a model out of this data, so that when a new retailer come in, right, I can use this model to predict the buying amount of the new retailer, right? That's basically what we want to do. We want to use the existing data to build a model, so that we can predict some other new retailer. Okay, that is the purpose. Okay, the way to build model is so easy in R, right? Now in R, in order to build a simple linear regression model, we only need a line of code. Okay. So in this line of code, as we can see that our target variable is the milk, okay, which is the kind of like the amount of buying on the milk product, right? So and so this is the target variable, and this is the regressor predictor. Okay, so I want to predict milk by grocery. Okay, so knowing grocery, I want to predict milk. Okay, so the way to write in LM is like this. This is the our target variable, and then you have a how to call this symbol, tilde. Okay, and after the tilde you put the predictor, the independent variable. Okay, and this is the data frame, right? So and this is the function that we used to build linear model. So this is the method, right? And this is the model. Don't confuse these two terminology, okay? LM, linear regression, is not a model, okay? Linear regression is actually a method, okay? And you use this method, you put the data, and you put the model spec into this method. This method would kind of like build a model for you, right? You would actually return an object, a model as a data object for you. And here we give it a name as MD, right? Actually, you can use whatever name you like to, okay? So to build a model in R is very easy, right? Very straightforward, okay? It kind of like just call the LM method function, and then you need to tell him what is the response, what is the predictor, right? You need to tell him what is the Y. You put the Y before the tilde, and after the tilde you put the X, and then you specify the data frame. That's it, okay? And this method with this model spec and data would actually produce a model for you, okay? That is the model. Now, in order to see what is inside the model, you use the function summary, okay? You use summary MD, and then it will tell you a lot of things, right? The most important thing is like intercept and the grocery coefficient. These two things, the estimate type of thing, these two things is exactly the B0 and B1, okay? I told you, right? I told you that this linear regression, it actually like will try to predict Y by a linear combination of X, okay? Which means that when you give the data to LM, it will find the B0 and B1, and B0 and B1 that would minimize the error, okay? That would do it automatically, so you don't need to worry about how to do that, okay? This two value is exactly the coefficient that would minimize the error when you want to use X to predict Y, okay? That would do, okay? The LM method will do it for you automatically. Question? No question, right? It's very, very simple, right? It's very simple. So as long as you know the coefficient, now you can do the prediction, isn't it? Right? Because you know B0 and B1, so by using this equation, given X, and you know B0 and B1, right? So given X, you know Y. So for every given X, you have a Y, right? Isn't it? So we can do that. In R, we can like do that. So there are some like this is the estimate model, right? So you know B0, B1, which is here already, and then you know X, then you can calculate Y hat. The Y hat is actually the predicted value of Y, okay? The predicted value of Y is actually lie within this blue line, right? So this is the predict value, and this is the actual value. And the difference between the prediction and the actual value is called residual, okay? All right, so Y is milk, right? X is grocery, and B0, B1. You can actually extract the coefficient from this model in this way, okay? There are two coefficients, right? So y hat is actually b0 plus b1 multiplied by x, right? Isn't it? Okay. So, and the error is the difference between y and y hat. You see that? Okay. So this is very simple, right? So building a model in R is like very easy. Okay, any question? No question, huh? Now we can plot the regression line. Okay. If we want to plot the regression line, and actually we know that the relation between these variables is like this, right? So this is actually just the, let's go into R. So here I build a model, and here is the summary of model. I will explain the detail of this summary later on. So, and then calculate the predicted value and actually calculate the error. Okay. Now we can like plot the regression line if we want to. So first of all, let's plot the data point, right? These are just the data point, okay? Because this is the, for every data point, for every one of these 440 data point, is represented by a point, right, here. And then before I draw the regression line, I actually plot the points. As you can see here, that they are correlated to each other, right? There are some relationship between x and y, isn't it? You can see it already from the plot. And if you want to plot the regression line, it actually only call this function fline. Okay. The fline function actually take two arguments. The first argument is the intercept. The second argument is actually the slope. Okay. So if I run this, I will add a regression line here, isn't it? Okay. Well, usually in practice, you don't really need to plot the line, right? I plot the line only for explanation purpose. Okay. In practice, you don't really need to plot it. Okay. Now there's another way to plot a regression line. Okay, this is not another way to plot the regression line. You can use ggplot. Okay, so if you want to do it in ggplot, this is the aesthetic, right? And x, y, right? So that would do a geom point. This geom point would like draw the scalar plot, and then if you want to add a linear regression line, you don't really need to build a model. Okay, in ggplot, you just specify you want to use a method to add a regression line, then it will add the regression line for you automatically. Okay, so it's even easier if you want to do it in ggplot. But as I told you, in practice, it's not necessary to draw the line, right? What you need is actually you want to do the prediction. Okay, you don't really want to draw the line. It's just only for fun. We should say that. So in practice, what you really want to do is to do prediction, isn't it? Right? You know the model and you want to make prediction by using this model. Right? The way to do prediction is, in order to do prediction, we will need some new data, right? As I explained here. Basically, you build a model, right? And you want to use this model to do prediction. And in order to do the prediction, you need some new data, right? You have some new x. So you have this x, and you put it into the model, and you will do the prediction of new y, right? The y you unknown, you do not know, right? So in the context, if for some reason I know that there are some retailer, there are some new retailer, and their grocery buying amount is 1, 1.5, 2, 2.5, 3, 3.5, okay? So these are the grocery buying amount of 9 new retailers. And I want to use the model to predict their grocery buying amount, okay? So what will I do? Well, you actually can do it by calling the predict function, okay? This is the model, right? And you know the model, you know the new data, and you call predict. Then you will get the estimated value, okay? Like this, right? You have the new data, you have the model, right? Then you call the predict function, then you will get the predict value, right? See? So this is the predict value, okay? So actually, besides the prediction value is actually the expected value, okay? We know that there will be an error between the prediction and the actual value, right? So sometimes we would like to know that the 95% of confidence interval, right? Isn't it, right? So the predict can actually, it can give you not only the expected value of y bar, it can actually give you the 95% confidence interval of y bar, okay? And it can also give you the 95% prediction interval of y bar, okay? Let me explain that before we check the code. Let me show you the result directly, okay?
Professor, the 9 values that we got, the y values in new data,
Yeah.
what does it mean?
It means that if you have a retailer and you know that the retailer's buying amount of grocery is 1, okay? The model would predict that the buying amount of milk would be 1.567. If you have a retailer and that retailer's grocery buying amount, you know that the grocery buying amount of this retailer is 3. Then corresponding to the 3, that retailer, the model predict that that retailer would have a milk buying amount of 3.037. With this model, you are predicting milk by grocery, right? Isn't it? So that knowing grocery, and the model will predict the milk for you, isn't it? So now we have the new data here, okay? So corresponding to this new data, it will predict the corresponding milk, the buying amount of milk for you. You got it? Okay, and actually, this number is not certain, right? We know that there will be error. Okay, the model will not like eliminate uncertainty for you, right? It just give you the estimation. It just give you the expected value of y bar given x. Okay.
So in the table, 1, 1.5, 2, 2.5 are the grocery stores?
Yeah, they are grocery.
So 1.5 is 1.5 grocery store?
No, I think the value is already taken. Oh, it's not 1.5 grocery store. It means that there is a grocery store. The buying amount of grocery is 1.5.
So they're buying.
It could be like 1.5 million or something like that.
Oh, got it. So if their buying amount is 1.5 million,
Then we can predict that.
how much they'll buy the next month?
No, we are predicting that if there is a grocery store if there is a retailer, the grocery buying amount is 1.5, then I can expect that his milk buying amount is 1.93. You get me?
Oh god, so 1.5 million is the total amount of groceries that the retailer buys. So if the total groceries is 1.5 million, then chances are that she or he will buy 1.9 units of
Milk.
milk. Oh,
Yeah, that's how it works, right? That's how that's what it means, right? Given grocery, I want to predict milk, isn't it? Right? Any more question up to now? Okay. So this prediction is actually just the expected value of y given x. Okay? The expected value of y given x. But the actual y would like still have some arrow, right? Along this expected value, there are some arrow. Okay? So if you also want to know the arrow, you can actually use the prediction value with its interval. Okay? You can get that interval. Okay? Let me, I do a plot like this for explanation. You actually don't need to worry about the codes, right? Okay, this is just for explanation purpose. In the practice, you don't need to plot this at all. Okay. So the prediction that we make is actually on this red line, right? This is the point that 1, 1.5, 2, 2.5, 3, 3.5. Okay, okay. So that is the regression line. And that regression line is actually just the expected value of y given x, okay? But the actual y will kind of moving along the line, right? There will be error, right? So if you want to know the 95% of y, you need to add this argument into the prediction, okay? So if you add this argument into the prediction, it will give you the 95% prediction interval, which means that, for example, when x is 3, okay, 95% of chance that the actual y will fall within the pink interval. You get the point? Okay, so the regression value, if you simply call predict, it will always just give you the expected value. Okay? And if for some reason you want to know the interval that will contain 95% of y, then you will need to when you call the prediction function, you need to add the argument. Okay? And that will give you the 95% confidence interval y given x. You got my point? Okay. But usually you will not do that. Okay. Usually, for most of the beginner of business analytic, what you really need to know is simply just the expected value. Right? Okay? I just want to use this plot to remind you that prediction is not usually the prediction and the actual value will have some error between them, right? Okay. All of the statistic method cannot eliminate the uncertainty for you. Okay. It just gives you a way to evaluate the uncertainty. It cannot remove the uncertainty for you. Okay, it just give you the expected value and help you to estimate with the uncertainty. Okay, it cannot remove the uncertainty for you. Uncertainty is still there. Okay. So usually you don't actually need to do the plot, as I told you, right? I do this plot just for explanation. Okay, let's go back to this model summary, right? I have a model and I do the model summary. Okay, so as you can see that in this model summary, it will tell you the formula, right? This is what we call by regression formula, right? Your y, your x. And because this is simple regression, so there's only one x. Sometimes you will have a lot of x to predict a y, right? Usually you will do that, okay? And we will cover that later on, okay? The reason that we start with this one is it's easier to explain, right? If you have only one x and one y, you can make this plot. If you have a lot of x, then there's no way to make this plot, right? Okay, so simple regression is a good way to like do introduction, right? Okay. Okay, so this is the formula, and this is the distribution of the residual, right? Which means that the error, the difference between actual y and the prediction, is the minimum is here and the maximum is this one, okay? Medium 1Q to 3Q, and this is the coefficient, okay? B0, B1, okay? As you can see that the estimation of coefficient, it not only give you the estimate value, it also along with this estimation, it comes with a standard error, okay, and also come with a p-value, right? These are the things that when you are learning inferential statistics, okay, sometimes the p-value is very important, right? Okay. We can say it this way, right? Okay. Actually, when this LM do the estimate these coefficients, as I told you, it cannot like eliminate the uncertainty. Okay, uncertainty is still there, right? So the B0 and B1 is just the expected value of the coefficient, okay? And they come with some uncertainty, okay? For example, like this if I want to examine the estimation of the slope for grocery, okay, the slope for grocery is estimated to like 0.73, but that estimation comes with a standard error, which means that if the coefficient of grocery, if we plot it, it is like, this is the mean, right? And the mean comes with a standard error. You still remember this one, right? Okay, so this is the expected value, and this is the standard error, okay? So these are the two things, right? So you plot it, you will see that this is the distribution of the random variable B1, right? Okay, so coefficient by itself is not a certain value, okay? It also comes with some uncertainty, as you can see that, right? And because this coefficient has some uncertainty, it also comes with a p-value, okay? You can actually treat the p-value as the probability that the slope of grocery is 0. Okay, which means that in inferential statistics, sometimes you want to make sure that there are some relationship between milk and between y and x. Okay, for each of the x, you will have a estimation, and come with this estimation, there are some uncertainty. Okay, and together they will determine whether the relationship between x and y are significant. Okay, if the p-value is like less than 0.05, we will say that x and y has a significant relationship. Okay, in this example, because the p-value of grocery is like less than 0.05, right? So we say that the grocery has a positive relationship with milk, has a significant positive relationship with milk. Okay? And the p-value, the significance, is not so important in our course. Okay? But they are important when you are doing like research method, when you want to write your thesis, right? When you are doing some academic research, okay? Because in that theoretical purpose, your objective is to kind of like verify the relationship between x and y, right? If your purpose is to verify the relationship between x and y, then you need to look into this p-value, right? So as long as this p-value is less than 0.05, you will say that the model infer that there is a positive relationship between grocery and milk. Okay? There's a significant positive relation between grocery and milk, and the p-value is this small. Okay? So you can actually treat the p-value as the probability that there is no relationship between the two variables. Okay? Let me say it again. You can treat, basically, this is not correct, okay? Not 100% correct. But basically, you can treat the p-value as the probability that there is no relationship between x and y. Okay? So if p-value is very small, there is only a very small probability that there is no relation between them. Then we will say that they are significant relationship between x and y. Okay? And in this case, because the p-value is very small, we will say that grocery has a significant positive relationship with milk. That is called inferential statistic. You kind of try to inference the relationship, verify the relationship between the variables. Okay. Now, in theoretical applications, as I told you that when you are doing your thesis, when you are doing research method, when you learn inferential statistics, that is important. Right? But for our purpose of business analytics, actually what we really care is the prediction. Okay, it's the expected prediction. Most of the time, what we really care is the prediction itself. Okay, so the p-value is not so important to us, but they are important in some other cases, right? After all, you are using regression not only for business analytics, you are also using it for research method, right? And in that purpose, you will need to look into this thing and this thing, okay? But in our case, we don't need to worry about too much about the p-value things, okay? So this is basically what we want to do in the first notebook. Okay. So in the first notebook, we talk about simple linear regression, which means that we only have one x. Okay, we only have one x. But actually, in the reality, in the real case, usually we have a lot of x to predict a y. Okay, so let's go into our second notebook. Okay. Question up to this point? Okay. In this notebook, I cover a lot of things like plotting, also and also like p-value type of things. That thing is not so important in our course, okay? But they are important in some other places. Let me go to B. Now we're talking in 9B, we are talking about multiple linear regression. So by multiple, I mean that we will have a lot of x. Okay, it's not just one x. We have 1, 2, 3, 4, 5, 6, 7. We will have 8 regression. We have 8 independent variable, right? We are using this 8 variable to predict this variable. Okay, so now let's take a look at the data set first. What? Why? What is the problem? Sorry, let me do it again. Looks like there are some problem here. I cannot see the data here for some strange reason. Do you have the same problem? I don't know what happened, but it worked now. Okay. So let's take a look at. So this is our data, right? Actually, this is the global warming data set. Okay, so year, month, and then these are our target variable, temperature, right? And these are the density of some greenhouse gases. Okay, so basically we want to use the density of these greenhouse gases to predict the temperature. Okay, that's what we want to know, right? We want to know that how the density of the greenhouse gases would affect the temperature. Right? That's what we want to do in this data, right? So we are making a regression using all of this density to predict the temperature. And this is the multiple regression because we are using multiple x to predict a y. Y is it's always only one variable, okay? That y is always only one variable, okay? And in regression, that variable is always a numeric variable, right? But you can have a lot of x to predict that y, okay? Yes?
Does that mean that x are linearly related to each other as well?
We will cover that later, okay? So we have the this x, and we want to predict the y, okay? So, but before we do the model, this time, we divide our data set into training and testing data, okay? I will explain that later, okay? So this time, we do not use all of the data to build the model, okay? We kind of like put the data before 2006 as the training data. And we set the data for after 2006 as testing, okay? Kind of split the data into training and testing. So after I do the split, I will have the training data set, I will have the testing data set, okay? And so if you add this up, it was like 308, right? Okay. Training 287 and testing 24. Okay. Now, the reason that we want to separate into training and testing is for measurement purpose. After we build a model, we want to test that how accurate the model is. Okay. So if I test the accuracy of the model by the training data itself, okay, that is not what we want, right? Because after all, when we talk about the accuracy of a model, we want to know how good the model, when we use the model to predict the data that it cannot see, that it cannot see in training, right? We want to use new data to test the accuracy of the model instead of using the training data to test the accuracy of the model, right? In recent days, if we want to evaluate the accuracy of the model, usually we will like preserve some data, right? And use the rest of the data to train for training. And then we are using this preserving testing data to test the accuracy of the model, okay? So the testing data is for, the purpose of this testing data is later on, we will discuss about how we can evaluate the accuracy of a model, right? And the training, of course, we are using the training to build a model, as you can see that. Instead of using D, now I'm using this training data to build a model, okay? And again, I'm calling this LM function, okay? And this is the Y, and this is all of the X. And, well, then I get the model, right? Actually, if you look into the model, it's a very complicated data structure, right? So in order to examine the data, usually we will use this summary function, right? Okay, and the most important thing is in this summary is, of course, the things, right? The coefficient, right? But now, because we have a lot of x, so for every x, there is a corresponding coefficient, right? And you actually can treat the coefficient as the marginal effect, okay, of each of this x, okay? Let's go to our... So this is the multiple regression mathematical form, okay? Because you have x1, x2, x3, x4, right? So, and corresponding to every one of these x, there is a coefficient, isn't it, right? So, so in this mathematical relationship, if x is increased by 1, y will increase by b1, right? If x1 is increased by 1, the estimation of y would increase by how many? b1, right? If x3 is increased by 1, then the prediction of y would increase by b3, right? So the coefficient, somehow we can interpret them as the marginal effect of each of these x toward y, to the prediction value of y. Okay, so as you can see that b is actually the estimation, the coefficient. Okay, and along with this coefficient, there are standard error. Okay, and there are p-value here. Okay, I already told you that standard error is the uncertainty about that coefficient, and the p-value is actually telling you, well, actually you can see it this way, right? So the p-value is the probability that there is no relationship between x and y. Okay? If the p-value is like 0.01, okay, then I would say that there is no significant relationship between CH4 and the temperature. Okay? And because this p-value is very small, right? So I would say that, let me use this as the example. The TSI p-value is like very, very small, right? So I would say that TSI, according to this model, TSI seems to have a significant positive relationship with temperature, right?
The asterisks that are besides the p-value, if there are 3 asterisks, does that mean that the relationship is more significant?
Yeah, yeah. So actually, there's a rule. Okay, if the number is less than 0.005, 1 second. Yeah, 0.005, then there will be 3.
Is that the confidence interval? 95% confidence, so it will be 0.05? Is that how we come up with that number?
Yes, yes, you can say that. You can say that this p number is actually talking about because we know its distribution, right? We know its expected value and we know its standard error, right? So we know it's 95% confidence interval, right? And the p-value is that the probability that 0 is within this 95%, 4 within this 95% interval, okay? Okay, so basically we can treat p-value as the probability that there is no relation between the two. Okay. See, actually, when we say that the coefficient, the estimation of coefficient is basically the marginal effect of x. Okay? Okay? And when we say that the p-value is the probability that there is no relationship between x and y. Okay? Simply put, we can say that, right? But if you are talking about if you want to apply some theoretical but as I say here that this inference are subject to a series of assumptions, okay? And when you are doing doing things like academic research, when you are doing some thesis, okay, sometimes this assumption would not hold, okay? So there are a lot of problems, okay? Simply put, you can treat it like this. But if we are talking about some very serious prediction, then you need to learn a lot of things, okay? Basically, you know that you should already learn some statistics. You should learn, some people would also learn research method. And some people would also learn econometry, right? So usually the econometry books is like more than 1,000 pages, okay? You will need to spend like 1 year to learn the econometry, right? So, and that 1 year you're actually dealing with this series of assumptions, okay? So if you are very serious about the accuracy of this coefficient, you really need to learn a lot more, right? But fortunately, to our purpose, I mean, if we only want to do the prediction, okay, you don't really need to care, you don't need to worry about too much, okay? See, let me if we only want to know if we only want to use the model for prediction, okay, so you don't really need to worry about too much about the accuracy of this estimation, okay. So I will explain that later, okay. It's already 11:04. Sorry. So let's take a break, and then after break, I will teach you that from our perspective, how do we want to use model, and then I'll give you some caveat, right? See that, and you cannot apply what I told you, what I teach you, to some of the research method, to some of your thesis that you're doing, right? You will get you into trouble, right? Okay, so that is what we want to cover in the next hour. Okay, let's take a break, and we'll be back in 11:15. Okay.